Hello. Okay. Welcome, everyone. Thank you for attending. My name's Chris Fantine, Chief Technologist for the Western region at Red Hat. I've been with Red Hat for about 13 years. I work with strategic partners and customers up and down the coast. Today's talk at DevOps State of Mind, Continuous Security with Kubernetes. We'll talk a little bit about some of the industry drivers in terms of DevOps, a little bit about DevOps, and then go into security and how you could integrate that into your DevSecOps practice. First off, Andy Grove talks about how only the paranoid survived back in the 90s when I was at Intel. And this wasn't about security, but it was about how there are moments of time in a company's lifetime when they have lots of massive change going around them and they have to make a decision. Do they go forward as is and potentially fall by the wayside, or pivot, take a risk, and change course and potentially thrive? And certainly Intel has had to do that numerous times through its history. In addition, you've seen this with other companies going on right now across many different industries, whether it's retail, finance, media, or transportation, right? The incumbents are being disrupted by the disruptors, and software is a huge part of that. And so what is the issue in terms of innovation versus execution? And that's a constant struggle many companies have. In terms of, most larger companies that have been around for a while are great at executing, right? They've come up with an idea and maybe 5, 10, 15 years they've run with it and they have tremendous execution. In this example, like Ford. But then they dial back on innovation, right? Because they've been successful and they don't take as many risks. And on the other side of the coin, you have a new company without any legacy, right? And they're really innovative. An example here locally is Tesla, right? They're excellent around innovation. Right now they're trying to be a great executor at scale. And so the average company, when it comes to software, their challenge is they're having trouble innovating, right? They're good at executing and they're struggling innovating and releasing new technology. It typically takes them 6 to 9 months to release new updates into production. And if you take a look under the covers, what's going on? As I talk with customers, you find out organizationally they're struggling because they're siloed off. They have their dev, test, and operations isolated. And just like in nature, if you're on your own island, you're going to evolve and come up with your own set of tools, your own set of processes, and it's become very difficult to communicate with that other group. And that's why it takes software so painful to move that application from dev test into production today. And so how does IT transform from being a cost center into an innovation center? And this is something that the disruptors have successfully accomplished. And what are the traits under the covers, right? It's not just a mobile application. It's not just a website. There's characteristics that make them allow them to innovate quickly and to rapidly release new software into production. Some of those are such as empowered organization, right? They've empowered their employees to make decisions at the lowest levels, right? Their hands on deck are able to make those choices. They're able to push into production without escalating. In addition, they're leveraging data, right? They're collecting that data and they're enabling the business. When they have a question, they're able to answer it because they have access to the data. They're able to analyze that, synthesize it, and they're able to respond quickly to changing market conditions or customer feedback. Thirdly, rapid innovation. Right? These companies are able to rapidly innovate because they've automated the pipeline from moving applications from dev test into production. And then IT has enabled the developers to experiment and try things out, right? Without the risk of failure, of bringing down the entire business. And they've done that because they've worked with the developers in terms of the architecture, decompose that large application, reduce the risk of change, and then automate that, allow you to experiment and try things out with real testing or real load. And if it doesn't work, be able to scale back to the older version. And so these characteristics are all around DevOps, right? DevOps is a cultural process and technology transformation for an organization. From a cultural perspective, it really mirrors and reflects a lot of the traits around the open source communities, right? Open source is about transparency and collaboration, bringing together cross-functional team members and be able to contribute, improve communication, and rapidly move forward with ideas because they have similar goals as well. Also, in terms of process, right, coming up with a automated pipeline, similar to like the manufacturing industry, right, having that automated assembly line, but for software. And that in the DevOps world, continuous integration, test early, test often, and continuous delivery, being able to deploy updates at scale. And then having a feedback loop so that you can quickly pivot and change course. And certainly technology is a big part of it, and open source has been a big part of early adopters of DevOps, whether it's at the lowest levels of the infrastructure or at development platforms as well. And really, these are the building blocks to build out what I call your software factory. Right? At Intel, the fab was a strategic differentiator over the years to help them stay ahead of the competition. Nowadays, in the software world, folks are building out this software factory, which allows them not only to innovate, but also to execute at scale. Right, and so the values around DevOps from a business perspective certainly are faster time to market. You have a more stable operating environment because you're decomposing that app and automating. Also improving the communication across the team and more time to innovate, right? You're freeing up your developers, freeing up your site reliability engineer to have additional time to innovate and contribute to actual business differentiating code. And from a technical perspective, certainly less complex, less risky, right? So if I'm deploying microservices, there's a lot less risk in deploying that monolithic app. And faster resolution of problems. With a CI/CD process and a feedback loop, I can quickly go back to development and then move that new update through the pipeline. And certainly security, which we'll be talking about today. Right, and typically, when I joined Red Hat, I would talk a lot of operations teams about security. Right, like get a lot of blank stares when I asked them how they patched their servers, and they said they had a firewall which surrounded their servers, and for the ones in the DMZ, they would patch those. But certainly, you know, over the years, there's been many vulnerability and breaches of those across many name brand, marquee brand here in the US. This represents over 1 billion data breaches a couple years ago, these logos. And so there's a movement towards DevSecOps, right? Integrating security into your DevOps practice. What does that mean? That means integrating a security-first mindset culturally in the organization. It's not just operations. It's your development teams, it's your testing as well. The entire organization, the business as well. They understand, certainly nowadays, the importance of security due to the headlines and the damage it might do to their brand. In terms of process, integrating security so it's not a chore, automating it so developers don't have to take on yet another task. Right? We'll talk about how. And then leveraging tools. There's open source tools out there to help you with your security in a DevOps practice, and we'll talk about some of those. Right? And so DevSecOps really reduce the risks, lower the costs around maintaining your application if it's secure, and then speeding up the delivery as well as recovering from security issues. And how does a DevSecOps, what are some of the ways to go about doing it is, first off, it's automating security through the pipeline. Also optimizing the process. It's not just a operations issue, it's a dev and a test. And then integrating into your overall CI/CD pipeline and continuously improving your security, whether it's through policy, scanning, and rollout. And containers are a big part of DevOps, right? They really enable you to have the ability to easily move your application from dev test to production without having to rebuild it, Also allows you to have a small footprint, so you reduce the attack vector as well, footprint. And so containers are really, a creation of this movement towards microservices, decomposing that app, so it's a very small API-driven service. It doesn't make a lot of sense to put a microservice into a 5 gig, 10 gig virtual machine, right? Container, very lightweight. That way you can just have what's necessary, starts up quickly, I build it once and deploy anywhere. It also integrates well with DevOps because you have the combination of your development operations groups and allows a clear separation of responsibility. Right? The developers own what's inside that container from an application perspective, and the ops owns the other layers as well as the host OS. And we'll talk a little bit more about that. And then thirdly, this movement towards dynamic infrastructure, scale up, scale down, allows you to easily move your application across infrastructures, and you want a format that's transferable across any environment, whether it's physical, virtual, private, or public cloud. And certainly containers with Linux allow you to do that. And containers, as I mentioned, have a clear line of separation, right? They allow that development team to define what's in the app and then just pull in those immediate dependencies and those dependencies could be other layers, so it could be a base OS, it could be the application layer, which are owned by other folks in the organization, so it frees up the developer from that responsibility. But at the same time, it allows that security and operations team to enforce without slowing down the development. And the basic flow of a container is really to build, ship, and run. Right? As a developer, I'm going to define my build file, defining what goes into that container, my application, its dependencies will be pulled in, and I'll produce a container image. And that image can be stored in a registry, whether it's public or private, and then I can distribute that to from my development workstation or laptop to my test environment. Maybe it's on public cloud, and then I pull it back into my private cloud for production, as is. Nowhere in the process did I rebuild it. And then I'm able to run it anywhere because there's a standard runtime, the Docker runtime in this case. Right? This is similar to the Java world if you're a developer. Right? I have my jar file, I have my JRE runtime. In the Docker world, same thing. You have a standard format, standard runtime, but it's for any language. But how do you manage containers at scale? Right? Docker is great running on a laptop, individual workstation, but I need much more when it comes to an enterprise, when I have 100 or 1,000 hosts, maybe spread across multiple environments. I need to be concerned about how do I schedule these resources efficiently across my infrastructure? How do I manage the life cycle of that container image from dev, test, and production? How do I manage updates when there's a security issue? How do I discover new instances and pull them automatically into a load balancer? Right? I want to automate that so I can scale up, scale down. And I want to be able to monitor that infrastructure and get feedback if there is an issue so I can automate the recovery by leveraging Kubernetes in this case, or I could actually have that alert my developers and make potential changes in my application. Of course, scaling, I want to have persistence. I want to be able to automatically provision storage. I don't want to wait for the storage engineer to respond to my ticket. And I want to be able to logically aggregate my several microservices that make up my application as well and be able to manage those without having to worry about all the details of whether that service is in high availability or spread out across different racks or data centers. And then certainly a security. How can I easily deploy security updates at scale? And so, part of DevSecOps is really managing at scale is where Kubernetes fits in, right? Container application platform to help you manage the deployment of containers at scale from a storage, network, and compute perspective, but also be able to manage those container applications in terms of the health, the scaling, and the continuous delivery of those updates And we'll talk about the different models that are built in. So first off, some of the basic principles around Kubernetes is it provides orchestration for you of your microservices. In this case, I have an example application that I'll be going through, which consists of 2 web front ends and a single database backend. And here I have the Kubernetes master, which is a controller manager, and then it also has a data store in etcd, which stores my configuration or the state of my environment. And so it's storing the state that I want to have 2 front ends and 1 back end. And so Kubernetes is declarative, and it'll ensure at all times that I at least have 2 responsive web servers and then 1 back end database. If not, it'll address it. And so in this case, it went ahead and rolled out my 2 web servers. And it did that by pulling down the container image from the image registry. In this case, it was running on Kubernetes. And then it deployed in what's called a pod. A pod can be 1 or more containers. It's treated as a single entity. In this case, it spread the load across 2 different physical servers. And then it went ahead and deployed the database, pulled down the database image, and deployed that. Next, it went ahead and set up these instances as a service. So it put a service in the front end of that web server, so a load balancer, so it's to be able to distribute traffic across the 2 instances, and then put a front end service for that single database instance. Kubernetes has monitoring and logging, so it's monitoring to make sure that the instances are healthy. If it detects an issue, in this case, on the right side, it detects an issue with the web server on that particular node. And so what Kubernetes will do is it automatically recover. It'll go ahead and deploy a new instance on an available resource, in this case, on that same node. And make sure it's in the 2-to-1 state once again. So it added that new instance to the load balancer, and then it removed the failed instance. So declarative, always maintaining that state. I didn't have to get a pager call at 2 a.m. to address that particular issue. It also can do auto scaling. So I can set thresholds. If utilization exceeds a certain number, I can actually automatically have it scale up. In this case, I set it to over 75%. It's at 80%. So Kubernetes detected this, and it's going to go ahead and deploy a 3rd instance of the web. It's going to go ahead and tag that as a web server. The load balancer, the discovery service will actually add that into the software load balancer in this case. And so now it's going to distribute that load across all 3 web servers. And again, that new state would be stored in my centralized etcd. So those are some of the basics around Kubernetes. What about security, right? How does it help me with managing containers at scale from a security perspective? So first off, we're going to talk about security on the top row: images, builds, registry, CI/CD, and the container hosts. First off, container image security. So one thing to be aware of as you're making that transition as a developer, typically probably delivering a jar file to your testing, to your operations team. If you're building a container, it's actually going to take your application and pull in any dependencies. That might be build images provided by your middleware and your operations team, right? But that final instance will be an image containing multiple layers. And so who owns the security issues at the different layers? You know, when I'm pulling down an image from the public internet, what do I need to be aware of? Well, first off, you know, what inside the container matters. On the left side, you see a C application container along with its dependencies that were pulled in from an operating system perspective. And the second, you see Java, also Node.js, and Perl PHP in the last column. The orange boxes indicate a component that was pulled in to my application that has a known security issue. In fact, the triangle indicates how many have been known, in this case, since RHEL 7 was released. So the JRE in the second column has a 66. Slide's a little old, but there's been at least 66 security issues for the JRE. So what does this tell me as a developer? I need to be aware of not only what's in the container, what known issues are in the container when I pull it down, but I need a process over time to be constantly checking this from an operational perspective. Right? And so, what about those layers? I, as a developer, does this mean I own the middleware layer and the OS layer now in my container image? Not at all, actually. You can still transfer over those separation of responsibility into a container world because you can build upon layers. So for instance, your operations team, the sysadmins, they can continue defining the OS layer. The unique thing now is, or the thing is now you don't have to worry about what language we're defining this in. I'm not defining it in the Kickstart file, I'm defining it in the Docker file. Likewise, the middleware team can define their layer in the Docker file, and the application developer can define it in it as well. So now we're all collaborating and talking the same language. I don't have a Kickstart file for one, a zip for another, and a jar for another. And so this improves collaboration. And I can continue from a security perspective with that ownership at the different layers. Also, you know, a best practice from a security perspective as well is also to treat your containers as immutable. Right? This means what goes inside the container image is simply your code and any immediate dependencies in that image. Kubernetes provides some objects which allow you to store critical information or configuration information separately outside of that container. And it stores it in the etcd. And so if it's not sensitive, security sensitive, I could put it into a config map, which could be set an environment variable, store, or a config file on instantiation. Or if it's a critical password or a key for encryption, I could actually store that into what's called a secret. Right? And so that could be encrypted, and so I don't have to worry about that being exposed as it's transferred from my etcd to my container instances. And then thirdly, you know, don't store your data inside the container. Leverage external service, leverage persistent volumes that can be provisioned by Kubernetes as well. And so that gives you a nice separation for your application. Another best practice, certainly at enterprise, is to sign your images. Right? So there's mechanisms which you can sign your image, and then when Kubernetes is launch that image, it can make sure that image is from a known and trusted source before provisioning it. Registry security, right? You know, talked about what's inside the container matters. We did a scan at the public repo. 64% of the images had a high or medium priority known vulnerability at the time. So very important to know where you're getting your images from. Best practices around private registries. It's pretty much the first step I see most organizations take is they set up a private registry within their enterprise. That way they have a known trusted source. Also think about 6, 12 months down the road. I need to go back and build and recreate that old version. I ran into a customer issue, and I got to go and see if I can recreate it. Well, if I try recreating that from a build file, which pulls dependencies from public repos, how do I know that public repo will retain that version 6, 12, 18 months down the road? I don't. I've lost control. I don't want to have that responsibility given up. Right? And I actually take ownership of that by putting a private registry and putting all my dependencies in there. So as an enterprise, I can always rebuild and I can back up according to my policies. What about continuous integration with containers? Right? The basic flow is continuous integration. Developer checks in their source code, and the Git, for instance, and then you do your continuous build, right? Take that source code, put it into RPMs, produce the container images, store it in your registry, and then I can distribute it to my production environment, my test environment, from that registry. Right? I'm always going back to the registry. I'm not modifying production directly. And so the CI/CD flow, from a security perspective, some steps here. First off, as you're checking in your build files, your source code into a repository, you'll version control that. Then you'll go to the build phase. Right? The build phase, when you're building out that image, ideally you want your images to be reproducible every time. Right? If I build it once and I build it a second time, I want 1 and 2 to be the same. One way to go about doing that is to make sure you're using a build image. So a build image will have all the build tools, but it will produce a second image with just your application that's built with its immediate dependencies. It will not have the build environment. Right? That way you don't have to worry about what's in the build environment. Right? And that is a best practice, kind of getting reproducible builds and then storing that build image in the registry and then pushing it into test. Another best practice with your CI/CD process is to integrate a security scan into the CI flow. Right? There are a couple ways to go about doing this. One is you just have a new phase, you call up a scanner, it scans the image for you, it produces a vulnerability report, you can address those. It also could check to see if your image conforms to your security policy. You could also, if you use a private registry, some third parties have registries that will automatically trigger or scan that image from a security perspective as well. Another best practice is to automate and trigger rebuilds if any of the layers are detected to be updated. So I, as a developer, built my application. I depend on the OS team. I depend on the middleware team. I have version 1 out in production. If the middleware team or the OS team updates their layer, I want to be alerted and then automatically trigger a rebuild and push that through my CI/CD process. Right? That may be a fully automated process. More likely, you have some checks in there before it goes into production. So best practices with builds, treat your Docker file as a build blueprint, so it's a recipe for how to build that image. When the original author goes on to his next assignment, you know how to reproduce it. Right? Similar best practice with Kickstart files in your Linux environment. Don't log in to the instance. Right? This is a bad practice I saw with virtual machines. People log into the VM, make 100 changes, save it. That's the golden image. Well, how do you reproduce that? When that engineer goes away, they don't remember. Right, so make sure it's in the recipe. Version control your files. Be explicit with the versions. Be mindful that every time you put a run in that build file, it's creating a new layer. Now, I talked about scanning and automating that. There's some many tools, Anchor, there's Black Duck, there's OpenSCAP, which I'm going to talk about today. OpenSCAP is an upstream open source project for compliance and vulnerability audits. The importance is not what tool you're using, it's that you're doing it, right? And best practice, around this is scan for vulnerabilities as well as does it conform with your policy, right? Define a policy. And so in this case, OpenSCAP comes with some predefined policies, best practices for different standards in terms of PCI, in terms of a virtual instance versus a container instance. So we have some best practices and guidelines. And then also, it comes with a list of known vulnerabilities as well. And then the tool itself is a daemon or a command line tool, which you can run against a physical, virtual, or a container instance at rest, or running, right? So against the image or the instance. And then Foreman is a tool to do it at scale. When you run this tool, it actually generates some reports. It'll show you compliance scoring, and it will show you any known vulnerabilities. Here's just a list of some of the default profiles you can leverage. So it predefines kind of best practices around security policy for different standards and types of use cases that you have. In terms of the security policy report after you run it, it's going to have things like, hey, did you set your minimum password correctly? If not, it'll trigger a fail. I can drill in for one of the failures, and it actually generates a script. At this point, it also generates an Ansible script to remediate that issue. So I could run that Ansible script against the instance and rectify that issue. It also will show you a vulnerability report of any known RPMs that have security issues. Now, what about continuous delivery with containers, right? I have out in production 1,000 instances. There's some vulnerabilities that were recently received notification about. I want to go ahead and address those at scale. Well, first off, no longer are we SSHing into the box and patching that box with the update, right? We go back to development and do version N+1 to address that security issue, right? So developer is made aware of that issue, they rebuild, they produce a container image, and then I put it through the pipeline, right? Why don't we do that today? If you have a monolithic app, typically that's not done because it took 4 to 6 weeks to get that monolithic app into production, tested, and trusted. When you go to a CI/CD pipeline, you're enabling your organization to push updates in a matter of minutes or hours. Right. And so this is just highlighting, do not log into your production servers. So I have 1,000 instances across 100 nodes. How do I update it? How do I ensure that I can test and deploy at scale? Well, Kubernetes comes with some built-in deployment strategies, such as recreate, rolling updates, blue-green deployment, canary deployments, as well as enabling your organization to kind of experiment and try things out with A/B testing. And let's walk through those. First off, recreate. Recreate with downtime. Right, so I have version 1 out into my production environment. There's a security issue. My developers go ahead and define that new 1.2, incorporates that security fix. I put it through testing. Now I need to roll it out. And so with recreate, I can just bring down my cluster and deploy a new cluster. Right? For non-mission critical applications, this is the simple thing to do. Right? I don't have to worry about backwards compatibility at the data layer or the API layer as well. So it's pretty efficient. But also, I have to have some downtime. What about when I don't need when I need to make sure I have zero downtime? Well, rolling updates is one way to go about it. That's when I have version 1, again, develop that new version to address a security issue. But I don't have a high confidence. There might be an issue with that new update. So I want to gradually roll that out. And so I'm going to go ahead and deploy a single instance. But before that instance is added into my load balancer, I want to perform a health check. Is it communicating with the backend database? Does it pass some other checks before I add it? And so built into Kubernetes, perform a health check. It could be TCP, HTTP, or some script. And once that's successful, then it'll detect that new service by the tags of that instance and update the load balancer. And then as I gain confidence, I can control the rollout gradually, 50 to 100%. Right? This is great for horizontally scaled instances, like your web server. All right. Also, you want to make sure, in this case, that you're backwards compatible, because you have two versions side by side at the front end, in this case. Make sure it's compatible with the back-end database. Some additional resource required, not a lot. Also, in terms of rollback, if there is an issue, I could actually roll back that instance as well. Next, I have blue-green deployment. The blue-green deployment scenario is when you have version 1 and call it your blue environment. You're deploying rolling all your traffic to that route. And then I have a security issue. I want to deploy that new version. Built it, but in this case, I'm going to create an entirely separate mirror environment. Right? So from a resource perspective, I'm doubling my resource consumption. So I need to make sure I have the infrastructure for that. But the advantage is now I have both versions side by side. All the traffic's going to the old version. And after I perform some testing, I can flip the switch. Right? Of course, if there's an issue, I can flip it right back. So I can deploy a lot more confidence that if there is an issue, I can recover from that issue very quickly. This is good for self-contained microservices where the data is within that instance, right? So you don't have to worry about replicating the data, especially if you flip back. There is resource overhead. Definitely a low-risk option if you have the infrastructure. And you're testing in a production-like environment as well very easily, because it's a mirror of production. Rapid innovation and experimentation. So how does Kubernetes enable that for your organization? Right, we talked about A/B testing. Right, when it comes to microservices, there's a famous quote by Ronnie Quavi from Microsoft Amazon, about only a third of the ideas improve the metrics they were designed to improve. Right? So there are a lot of surprises out there. And one of the things is you need to have that feedback loop so you know about them. And then two, I want to be able to experiment, try things out with confidence. And that's the main thing about DevOps, besides CI/CD, is at that feedback loop. So I can pivot quickly and change course. And Kubernetes has built-in monitoring, Prometheus, as well as logging, so I can aggregate central logging and view that. So in my A/B scenario, on the left side is my existing app, and on my B side, my developers came up with a new idea. Hey, I think if we alter some of the recommendations through our recommendation engine, we may actually see an increased click-through rate. Let's try that out. But I want to try that out on live traffic. And so with Kubernetes, I can do that. I don't have to write scripts. I can do a deployment of version 1, and I'm seeing a 25% conversion rate because I'm monitoring that with a third-party tool. And then that new version is in 1.2. This could even be a security issue. And then on a route, half of my traffic, maybe it's my European traffic. It's in the evening, it's not critical, but I do want to get a sense of the conversion rate. And here I see that actually improved by changing that recommendation engine. So I'm getting a better conversion rate, and so I'm going to go ahead and deploy 100% of my traffic over to that new version. If there was an issue, maybe I saw a decline, and I correlated that with the actual change I made, I'm going to revert my traffic back to the original version. So that's deployment strategies. Helps you deploy those security updates at scale in an automated way. No longer do I have to write all this infrastructure scripts that my development team is typically doing for my automated CD pipeline. Instead, I freed them up, allowed them to innovate and to focus on new business logic. What about container host security? Right, when it comes to containers, containers are Linux. And we say that because there's a lot of core security capabilities built into the operating system to ensure that you have a secure enterprise container platform. Those include C groups, namespaces, SE Linux, seccomp, read-only mounts, and we're going to go through those. First off, C groups. Control groups, they provide resource isolation. Google, many years ago, developed this, put this into the Linux kernel, but it allows you to address the noisy neighbor problem of sharing the same infrastructure. It allows you to ensure a process doesn't over-consume when another process needs its assigned quota of CPU, memory, network, storage. Right? So the business unit doesn't have a right to complain. They don't have to worry about it. Second thing is namespaces. And most importantly, the process IDs and network. This allows the container to have unique process IDs and network that don't conflict with the other containers or the hosts. So root user in a container is not root user at the host. Why is that important from a security perspective? If there's a breach at the container level as root, I don't become root at the host level. Because if I did, then I could go into all the containers. And network, right? I want to have 13 applications on a single physical box with all their own networks, and I don't want one application to be able to talk to the other application. How do you do that? Well, network namespaces allows you to have that nice logical separation in a secure manner. Mandatory access controls, SE Linux, right? If I'm root on a box, I can do whatever I want, typically, but if I have SE Linux enabled, that user or that process can only access objects that it's explicitly stated to have access to. Right? So if there is a security breach, it can only perhaps access the httpd.conf file. Right? It can't access everything else on the disk, so the temp space, etc. Seccomp, that allows you to kind of drop privileges for a process so that it doesn't have all complete access to all the kernel level privileges, right? So you can minimize that. And then read-only mounts, right? Mount your file systems read-only so you can't actually have writable access. So those are some ways that Linux helps you secure your containers. Here's some best practices. You know, don't run your container processes as root. Don't SSH into them. Make sure you're using namespaces. Define resource quotas. Enable logging. Make sure you're applying security route not just to the instance, but also the host that it's running on, right? And the seccomp filters. Take advantage of that. Lastly, we're going to talk about network isolation, storage, API and platform access, as well as monitoring, logging, and federated clusters. How are we doing on time? Okay, great. So first off, network isolation. Right? We talked about network namespaces. This allows you to do a lot of powerful things. On the same infrastructure, I can have dev test and production. Right? I just logically separate it using my network namespace, so I have isolated environments. Very powerful. Right now, I can have a mirror of production on my laptop, a mirror of production in my test environment. I don't have to open a ticket for that standby data center to experiment and try something out with a load balancer change. And I can have n number of these environments to experiment and try out. I can also confidently do things in parallel. So I talked with one customer, they have 13 different test environments because they're a credit card company and they have different security processes they have to put these apps through. What if I could have 13 virtual environments in parallel pushing that process through? If there are no dependencies, I could greatly speed up that overall testing without huge amount of physical infrastructure increase. A network policy is a nice, relatively newer feature, which allows you to explicitly state which ports or which containers a container can speak with or communicate on the network with. So this allows you to even have a more finer, granular control over network communication. Storage security. Built in, you can set constraints in a security context in terms of who can access the storage. You can also define resource quotas for your users so that they don't exceed them. And at the same time, you can enable the storage to be automated in terms of provisioning by pre-allocating. API and platform access. So one of the key issues as we go to microservices, you have all these APIs. Are you managing the security to those APIs? Or can anybody provision a new cluster, a new instance? And so there's integration in terms of authentication and authorization. So you can limit who can access, in this case, the Kubernetes APIs. But in practice, as you develop these microservices, you want to think about the security implications, the quality of service to these APIs, and be able to put some policy enforcers in front of those. And that's an area of development. Istio, for example, is a popular project in terms of providing more capabilities around that. Monitoring and logging. Built-in logging, so you have central logging. From a security perspective, I can scan and be aware of issues. From a monitoring perspective, I can view the state of my infrastructure, if there's any triggers or alerts, and take action. Another area of development is around federation. Right? Federation, there's a project Kubernetes to have kind of a master API that can interface across multiple clusters. This is great from a security perspective because then I could have a single API, but I have different clusters that have different levels of security rating, right? Maybe I have my public sector cluster and I have my commercial sector cluster, right? Or in a production capacity. Or I want to span that across multiple providers and kind of totally abstract if that app is going to public or private cloud as well. In terms of your transition to DevSecOps, how do you measure success? What should you be looking at to see if you're moving in the right direction? Certainly compliance scoring around vulnerabilities and security policy, but also how often am I deploying? Am I improving my frequency versus the manual way? What's the lead time? What's the failure rate of my deployments? I want to be measuring and tracking that. And when there is that security issue, how long does it take to recover? Right? And certainly, service availability from a business perspective. So with that, I want to thank you for attending today's session. I am available on LinkedIn. Also, here's my email address. Feel free to send that, Twitter. And then I'll be around in the back after the session as well. Thank you very much.